Tune into this week's Xamarin Show where I have my good friend Kerry in all the way from Germany. Kerry, what are you talking about?
I'm talking about app security, how to get your app secure.
Oh, I love it. It's super important for mobile applications nowadays, so make sure you tune in. Welcome back, everyone, to the Xamarin Show. I'm your host, James Montemagno, and today we're going to be talking about mobile app security with my good friend all the way in from Frankfurt, Germany, Kerry. How's it going, Kerry?
Good, how are you?
I'm really good. I woke up super early this morning because we got a slot really early in here in Channel 9. And who doesn't want to wake up at 6 a.m. and talk about security?
I got up at 3.
Exactly. So Kerry wins all the time. So Kerry, first, you're in Microsoft MVP Summit's going on. Can you tell everyone a little bit who you are, what you're here to talk about, and a little bit about your background?
Right, my name is Kerry Lothrop. I work at Zulke in Frankfurt, Germany, and we do projects for customers. We don't have our own products. Increasingly in these projects, security is a big factor. So we try to get the type of projects we're doing, they're not just your app, marketing app, something like that. But usually there is something connected, like a Bluetooth connection, a real device. People pay a lot for the product and they get an app where they have certain expectations about the quality of that app, and that of course involves or includes security. So that's what I focus on.
Got it. That makes sense. And I've seen you a lot of time speak at Evolve. I've read your blog posts. And I think when people think security, often they're like, oh, I've encrypted a string or I've encrypted my database. But that's not what we're talking about today, correct? We're talking about something different.
I was going to focus on network security because I see a lot of people are doing things wrong there. So that's what I was going to focus on today.
Well, yeah, and I think when I think of network security, I've always heard the joke, or maybe it's not a joke, that HTTPS, right? Just put everything through HTTPS. Is that good enough? Is that good? Is that bad? Is that the silver bullet of security?
That's a good start. So HTTPS is, well, on mobile, if you want to do some sort of connection, it should be HTTP because usually a mobile phone can be inside a network that will not allow anything else.
Okay.
You're in the coffee house, and they won't allow any like direct connections to SQL Server or something like that.
Of course, yeah.
It's always HTTP, but if you want to be secure, it's HTTPS.
Got it.
And you know HTTPS from the web world, so you type in the URL up there, and as a
Get
user,
that little green, secure, makes you feel warm and fuzzy
or
inside.
maybe it's yellow and makes you feel good.
Yeah.
And the user, or like my grandmother, can see, right, this is secure. This is my bank I'm talking to. I can enter my credentials. And with apps, you don't have that. You can put a lock icon in your app, but it doesn't really do anything.
Yeah.
So the people are entrusting you as the developer to do everything in a secure way and to make sure your data is handled correctly.
Yeah, and I think we'll focus on network security. I've always think of not embedding strings into my application and securing things into there's the key store and the keychain on iOS and Android. And those are other things that you should just be doing to secure your data in your app. But
right.
I think when I think of network, it's like, how is the data coming and going to the application itself, and making sure that someone's not swooping in there in those coffee shops. I do some work sometimes in the coffee shop.
I heard, yeah.
And it happens. You're just there, and at the same time, everyone's on that public Wi-Fi. I think more nowadays, why I think this is more important is we're always so connected, not just with our laptops, with our phones. I travel half the year. I've connected to Boingo internet 1,000 times at this point. Right. And the security model on that is not the same when I'm on Microsoft CorpNet, right? I'm on CorpNet. Things work, things don't work because IT is locking things down. But you're right. I think more more as we see these large companies go through security issues and hardware, we should be pretty cognizant of this.
Right.
Yeah.
And well, you say you're in the coffee house Wi-Fi, but you don't actually know that that's the coffee house Wi-Fi. Actually,
it's true.
It could be some other Wi-Fi because not only does your phone scan, are there any Wi-Fi's near that I know, like is the this coffee house or this airport nearby, they also broadcast that information out. So they like shout out, I know this Wi-Fi, is it anywhere close? And then as an attacker, you just have to respond, yes, I'm that Wi-Fi. And your phone will connect to it automatically without you realizing that. And the good news is if you do your homework regarding security right, then it doesn't matter if the connection is bad or if there's someone in the middle, because it will either work and be secure or will not work at all.
Yeah, and that makes sense. So what we're really seeing in that scenario then is this kind of bring your own device. You're in this corporate environment. Your employees are going out with their devices. No matter where they go, what Wi-Fi they connect to, what you're going to show is going to show us how to make that secure.
Right.
Yeah. So let's do it. Let's jump in. I'm ready. Can you kind of talk about your setup here a little bit? You got some phones and some adapters here. Yeah, let's kind of walk through what you got.
So I've got Mac here. I'm using Visual Studio for Mac, the update from yesterday. So let's hope this works. I've got a phone connected, so it's a real device. You see the icons are jiggling. And I've got a Windows VM here, and I'm running a tool called Fiddler from Telerik. I've set up my phone so that the traffic from the phone runs through a proxy server, and I entered the IP address of the Windows machine. It has its own IP address because I have a network card here, another Wi-Fi USB card. That's connected to the same Wi-Fi, and the traffic from the phone is running through the proxy server here. And so I can basically see what the phone is doing. And
yeah, this makes sense because even the beginning of trying to secure your apps is how do you even do it? And you're like, I need this network and this and this. And this is pretty interesting because everything's on the same network, but you're essentially going to be piping your data through your Windows VM or Windows virtual machine to see every little bit of traffic, and we see some iTunes stuff happening, I guess.
Yeah, this is the phone communicating to its home base.
Very cool.
Right. Yeah, so this would not be how you, well, usually people don't set their proxy server to this, but this is what somebody in between you and the server you're trying to reach would be able to see.
Got it.
If he were a man in the middle.
So we can think of this Fiddler session as the man in the middle, someone that may intercept and see all of your traffic.
Right, and we'll see what that person would be able to see.
Awesome, cool.
So what I've done here on this side, I wrote a not so pretty Xamarin app, and it has one button, and if you tap that button, this code gets called. And what I had to do here is I set up the Fiddler as a proxy server itself. It's a little Xamarin detail. The Xamarin has a re-implementation of the HTTP client, and if you use the default one, it's going to be the mono implementation, the real .NET implementation, and it ignores the proxy settings on my phone. So for this test, I just entered that here.
So basically, if you were using CF networking or the other stacks, it would go through that. But since this is our implementation, it makes sense that you're using the HTTP client handlers.
But then other things, other features of the HTTP client might not work. So this is the one I picked for the demo.
Makes sense.
And I have a blog post where there's a list of the possible HTTP client handlers, and you can see which ones have which features. So
that's good.
Yeah.
I had someone asking me about that literally on Twitter yesterday, so I'm going to go find and send that out. I just use the default. So this is what I think probably most devs are used to.
Right. Yeah. So what I want to do here is just do a plain get HTTP call on Microsoft.com, and if it works, we'll show a pop-up success, and if it doesn't, we should see an error message right here.
Okay, cool.
So I'm just going to run that on the phone.
So this looks like, to me, just kind of standard networking calls. I've used HTTP client 1,000 times. I've made very similar calls. Now this you're just getting, and this get is anything, essentially the page. But a lot of people are probably used to getting string, getting stream. Is that accurate? Is that the same here? Essentially, it's just get async.
Right.
No matter what you're getting.
The normal HTTP get. Yep. Right. So I'm going to tap make call here. And what does it do?
Success.
Success. So what we see here on the Fiddler side, we see there was a call to Microsoft.com. And with the inspectors here, we can look at what was inside. the headers, and this is raw call to Microsoft.com, and this is the response, and will probably be some redirection to a secure site maybe, or maybe it's just the whole website in one line.
Nice. Yeah.
But so I'm getting results. The app thinks it got result from the server, but actually someone in the middle was able to read that.
Yeah. So literally right there, we could see that entire request fully and the response fully too. I think that's the important part, is that everything's plain text.
Right.
Is that because it's HTTP?
That's because it is HTTP,
okay,
right?
Got it.
So what we could do, you know, Microsoft is available through HTTPS too.
Yep.
So I'll just try that. Add an S here, and I'll run that again.
Yeah. So essentially, if you own the back end, kind of out of the box, I know if let's say you're hosting on Azure, Azure websites, you're going to get HTTPS out of the box.
Right.
If you set that up, and then I know also, if you're using a custom domain, though, you're going to have to use some cert, like Cloudflare or the other cert kind of server, right? You have to set that back end up somehow.
Right.
So Microsoft obviously has done that, which is why we have HTTPS. But you can't just add an HTTPS and have it magically work, right?
Your server has to support it, but you don't actually have to buy a certificate. We'll get to that later.
Okay, cool.
So let's see what it looks like here. So I'll tap Make Call, and we should be seeing a response. So, okay, it gives an error message, certificate unknown. Oh, this is something else. No. Okay, this was expected. So what we see here in Fiddler is it's trying to connect to www.microsoft.com. And what happens, I make the request to the debugging proxy. The debugging proxy makes a request to Microsoft.com. So, and it gets a response, decodes that response, and encodes it again for my client.
Okay.
And so the client gets a different certificate for that than it would from the original server. So I can tell that apart, or the user agent can tell that apart. So it's saying here the certificate does not match. I don't trust www.microsoft.com. It was if I were to call this in a browser, I would see it's issued by a root authority called Do Not Trust Fiddler Root.
Oh, okay, got it.
And this is what's happening here. So, but even this, I could show you how to intercept this. This is a neat trick. You can call this URL up here. It's called IPv4.fiddler : and then the port number that Fiddler is listening on. And then you see some information about Fiddler here, and it says you can download the Fiddler certificate, and it will give you some warning messages, and I can install the Fiddler root certificate on my phone. And it says here more details. So this is the name of the certificate. Do not trust Fiddler root. And it is basically issued by my computer here, and that's by the Windows machine, and that's why the other computer doesn't trust it. So I can just tap Install here. Then I have to confirm that I want to install. Then I have to go Done. Then I have to go back to the settings. This is really interesting. Under About, then down here, Certificate Trust Settings. There I see the certificate, and I have to explicitly say I want to trust this.
For
I say
real.
Trust. Yeah, then I get asked, do you really want to trust this? This is really bad. And when I do that, then my this is not going to work. But my operating system will then trust Fiddler for all requests. So I just realized this will not work because it's the HTTP client from Xamarin, and it does not value those. Let's see if it works. Okay, I'll just give it a try. Okay.
So what essentially has happened here is the Microsoft server is not trusting their certificate that Fiddler is passing. Is that what's happening in the scenario of debugging?
So what happens, the client gets a response, and it has to somehow, HTTPS is nice. It means I've got a secure connection, but you don't know who you're talking to.
Got it.
So the way it works is I have a list of root certificate authorities that my operating system knows. iOS has that list, Mac OS, Windows has a list, and it's a list of 200 authorities.
Got it.
You can look at that list here, system roots.
Oh, I see.
And
all the
it's a
trusted
big
services.
list of all the companies that my computer trusts.
Got it.
And what I did was I added Fiddler to this list.
Got it.
On the phone.
Got it.
So now the phone should be able to trust Fiddler. Let's see if it does work. I'm not really sure. And I don't know why it's so delayed. Success. Okay, it did work.
Cool.
So it's using the root certificate list on my operating system. And what I can do here is I can look at all the contents. So it's an HTTPS call.
But you can see everything.
But I can see everything, right.
And is that because of the trust between them? But I always thought, HTTPS, everything's encrypted, everything's magical, right?
Right, but that's because I installed the certificate of the man in the middle onto my phone. So this is also not a typical attack vector. You would have to have physical access to the phone to do that. But what it does show you is the whole HTTPS stuff is built around browsers, and browsers rely on this root certificate list here to authenticate any type of website you might encounter.
Got it.
And when working in a mobile app, that is not really necessary because you don't have to just trust any server. I'm going to talk to my server. And I want to trust this server, and not just any server that my operating system trusts.
Got it. This makes sense. And that's what's essentially happened here is because we installed this cert, we're like, hey, everything's great, and kind of look and add this cert in, and now anyone could really use that cert at this point, but I know that I'm going to be talking to my Azure website, or I'm going to talk to my backend that's hosted somewhere.
Right.
So we should be able to, make that handshake, right? Is that the idea?
Right.
Is we can trust each other.
That's the idea.
Yeah.
Yeah.
So right now we're trusting everybody.
And this list, you sometimes see it actually modified. Like there are manufacturers of PCs that install their root certificates on there, or there are companies that install the company root certificate on each employee's device so they can listen to the traffic.
Got it.
And it's kind of not a good idea to trust this list. And
Got it.
Yeah,
especially on a phone where and your own app where you know exactly what's going on. So can we secure this app then and make it all fancy schmancy?
So the next step would be, I could say, this is the code up here. I want to add some code to do the verification of the certificate myself.
Okay.
And what I'm doing here is I specify this function here. And what it does is it gets all the information, the certificate and the chain and any errors, and it looks at the public key, and it compares that public key to some magic string up here. And this magic string is the actual public key of the web server I'm using here.
And that's okay to put in the app because it's the public key.
Right. This is the public key.
Yeah.
It is the server will tell it to you if you ask it.
Got it.
And if somebody manipulates that only affects his own app, not all the other installations.
Okay.
So what I'm going to do here, this is now active, and I'm going to debug this again, or run this again. Okay.
There we go. Build. So this is a really easy check, essentially. So this comes in, and is this happening every single callback, essentially? And the handler is going to get this callback?
Right. Every website you access is going to check, is that actually this exact server? Does it have this public key? Because if it has this public key, that means it has the corresponding private key. Because you couldn't generate a public key
without it.
Or the corresponding private key for that public key.
Got it. Cool.
So now we got the app running again. I'll hit make call, and let's see what happens. Okay, I get an error message again. So even though this thing trusts Fiddler, it doesn't work because it's not. I don't want just any web server. I want this specific web server.
Got it.
Yeah. So what you can also see here, this other line is I only want to trust a specific level of TLS. The latest. All the prior versions have already been hacked. and the web server will, or basically the client is written so that it will work with older servers.
Okay.
But why should it? Because I know I'm calling my own server, and I
Yeah.
know it is up to date, and I only want to allow that. And you can also do it vice versa. Why should the server trust a client that says, I only know SSL2, really from 15 years back,
Yeah.
when it knows my client understands TLS 1.2?
Yeah. So we should use,
Right.
yeah. Not only am I only going to, if I get the request, I'm going to check at that point, and then also in the phone, I'm kind of double checking.
Right.
Which is really important. Cool.
So this is called certificate pinning, or certificate pinning and version pinning, or actually this public key pinning. I could do this at a greater scale, or think through this a bit more. I could check the certificate authority that it is issued by my company, maybe if I want to rotate the certificates. But the certificate doesn't even have to be trusted by the operating system. I could use a self-signing certificate on the server side, and then have its public key inside my app, and still this would be much more secure than just relying on the root certificate authority list.
Got it. Okay.
Right.
So now even if we run this, it's going to be the same error message essentially that pops up?
With the TLS 1.2? Yeah, that's the same. This didn't matter any for this demo, yeah.
Got it. Okay. Nice. So at this point then, is the mobile app secure because of this at this point, or what's the next steps?
This is much more secure. So there are other things you can do from the, let's talk about the backend side maybe.
Yeah.
So I said before, maybe you only want to trust this certain versions, but sometimes, okay, the big picture. The app now knows exactly it's talking to my server.
Yeah.
And then oftentimes we have people saying, I have this backend and I want to make sure it is my app, it is only my app that's talking to my backend.
Got it.
And that is something that's very difficult. So what people start doing is they send along credentials or send a client certificate, and they want to make sure this is actually their own app that's calling the backend.
Yeah.
But that doesn't usually work because you have to embed that information that this is your app inside your app bundle. That gets put to the store. And
I've seen that often where you're like, I'm going to put the certificate inside of it. I'm going to put all this information inside the app. But then what if your app, someone busts it open, right? At some point.
Right, yeah. So then people try to hide it inside their app, encrypt it, or hide it in the last bytes of an image resource or something like that. And but at one point, it gets passed to the API call, use this client certificate.
Yeah.
So if you're dynamically instantiating the app, you can look into that and basically scrape the certificate, and then you can make those calls to the server. So basically, what you should be doing is don't authenticate your app. Think about authenticating the user.
Got it. Yeah.
Like a website would. Yeah, you don't write a website that only works with Opera, this version of Opera, and you write a website, you can access it freely, but if you want to do something special, then you can, you log in and you authenticate the user.
Got it.
And then you can also block one user. You can remove his access, but if you have this certificate out there on every app, and it gets compromised, then you can't pull it.
You can't pull it, and you can't expect everyone to upgrade the application either, because we all know that people linger on the app updates. So now this application, this code, since you have the public key in here, if you then were updating and hitting the server where the private key was, then you're going to be able to see everything, or is it all going to be encrypted inside of Fiddler?
With this, I can't intercept it with Fiddler anymore.
You can't intercept it.
Right.
Oh,
I would have to
got it.
look inside the app. Like if maybe on a rooted Android device, I would be able to look inside the app and see what are the calls that are being made.
Got it.
But I can't intercept this anymore.
Perfect. So kind of recap, and you can correct me if I'm wrong here. First, obviously, move to HTTPS.
Right.
Then also ensure that you're doing your actual public key checks, that your backend has a private key, right? That it's all set up that way. And also at the same time enable TLS 1.2 support, on both ends. Only,
right.
And that's it. Because why do any other ones? And
Yeah.
in fact, I've noticed over time a lot of the services I've called have required 1.2, which is then we had to kind of select the different implementations of HTTP client, but all the Xamarin stuff now uses TLS 1.2 out of the box. So it's all built in for you. So it's all there. Don't think you have to go through any crazy other network code. If you just use HTTP client, you're good. Cool.
Right.
Awesome. Anything else you wanted to show off or cover at all?
That was about it.
Awesome. I love it because not only did I actually learn how to use Fiddler in this huge crazy setup, so now I can actually start debugging and look at all my applications, but you can see that there's actually not that much code. It's just it's all built in, really, and just changing a few URLs, making sure your keys are in there, and thinking about that, I guess, is important.
Right. What you can do is just be that man in the middle. Look at your own app, see what you can see, and that is what somebody else could be seeing.
Yeah, I like that. Awesome. Well, Kerry, thank you so much for coming on and showing this off. We'll put all your blogs, all the links, and I think even to your Evolve talk in the show notes below. So yeah, thanks for making the trip out here.
Thank you.
Yeah. Well, until next time, this has been another episode of The Xamarin Show. Don't forget to subscribe. You can hit that little button down over there, up over there, ding that bell to get notifications right in your inbox each and every week. Until next time, I'm James Montemagno. Thanks for watching.